Hello everybody, we're getting ready to do lesson 1.4 part 1 pre-algebra math today. And the classwork sheet has 30 points on it. Have that out in front of you. Your notebook will have 16 points worth of notes to take. Name, date, period, students on your classwork sheet. Due date for onliners and homeschoolers. And for today's bell work, we have a word problem here and then a continuation of the word problem down here. And let's see, you and your sister shall self-service. You divide the bill equally, including the monthly fee of $39 plus 30 cents for each additional minute beyond your free minutes. Write expression for your share of the bill in a month when you are charged for M extra minutes. So put that here. And then students down here apply 1 month you are charged for 125 additional minutes. Find your share of the bill. So give your students about 5 minutes for this, teachers. See you in 5. Okay, everybody, welcome back for our solutions. Here's part A of it. Let M equal the number of extra minutes. Your share will equal monthly fee plus cost per extra minute times number of extra minutes. And this will be for the number of people here over the number of people, which is 2. So 39 plus 30 cents a minute, cost per minute times number of extra minutes. We don't know that yet, do we? So 39 plus 0.30 M over 2. And then down here, you're charged 125. Find your share of the bill. So when you plug in 125 for M, you go ahead and 39 plus 0.30 times 125 divided by 2. 39 plus 30 times 0.30 times 125 would be 37.5 divided by 2. 76.5 divided by 2 is $38.25 for your share of the bill. And yeah, here's our plug-in here. M, we plug in 125 for M. And then this is where it's multiplied down here in our vertical format here. And this becomes 76.5 when we add 39 and 37.5. We come up with our final solution. Into your notebook, students, supercooled insects. Water freezes at 0 degrees centigrade, but some animals can resist freezing by producing a chemical that lowers the temperature at which the water in their bodies freezes. This temperature is called the supercooling point. Which of the insects listed in the table has the lowest supercooling point? So copy this down, put this in your notebook, slide 1. We're going to at least have a table here showing these supercooling points, negative 54 Celsius, etc. here. So these are supercooling points. The numbers in the table are negative integers. Each one of these are negative integers. The integers are the numbers negative 3, negative 2, negative 1, 0, 1, 2, and 3. These are integers here. The dots indicate that the numbers continue without end, both positive and negative directions. It can also be called an ellipsis here, actually, but we won't go there. Negative integers are integers that are less than 0. Positive integers are integers that are greater than 0. So here's a number line here. So these will be negative integers here, negative integers. And then these are positive integers this way here. Okay. And now for you, in your own words, students, define integers and define positive integer and negative integers. Let's go into our first example here. Graphing and ordering integers. To determine which insect in the table above has the lowest supercooling point, graph the integers on a number line. So here's our number line, and then here's our graph of the supercooling points of the previous table. Negative 70, negative 54, negative 35, negative 19, negative 9. Here's 0 here. Here's your origin. So we're way over here with our negatives. This will be the positive side of the number line. So read the numbers from left to right. Negative 70, negative 54, negative 35, negative 19, negative 9. So answer, at negative 70 degrees, here's the answer. To determine which one has the lowest supercooling point, it'd be negative 70 degrees Celsius. The woolly bear caterpillar, which here is your woolly bear caterpillar, has the lowest supercooling point. Okay, let's go into an example here. Graph the integers on a number line, then write the integers in order from least to greatest. So we're going to plot these. Students, use a number line to order these integers from least to greatest. This is your independent practice. This is the guided practice up here. We're going to do this in class. So for that situation, graph the integers on the number line, then write the integers in order from least to greatest. So 15, negative 8, negative 4, 7, and negative 5. So here's our graph. Here's negative 8, here's negative 5, here's negative 4. Okay, and then here's positive 7. Now here's our origin here. So we have positive 7 and then positive 15, correct? The integers in order from least to greatest are negative 5. From least to greatest are negative 8, negative 5, negative 4, 7, and 15. So that would be in order from the least to the greatest. Okay, so absolute value. What is absolute value of a number? Is its distance from 0 on the number line. The absolute value of a number A is written as, and then you have these two bars here, these two vertical bars, and then A, the number in the middle. You can use a number line to find the absolute value of a number. So here's a number line. So, okay, so how do we do that? Well, let's do example 2, finding absolute value. So A is 5. What's the absolute value of A? So we go from 0 to 5 is 5 units. So the absolute value of positive 5 would be 5, wouldn't it? State the absolute value of the number. So the absolute value of 5, absolute value, these are your absolute value bars here, these vertical bars. Distance between 5 and 0 is 5, so absolute value of 5 will be 5. It's 5 units from the origin. Okay, that's cool, Ruff. What's next? Okay, find an absolute value again. State the absolute value of the number. So now we have negative 7. What's the absolute value of negative 7? So here's 0, here's the origin, and we go over here to negative 7. We plot that. How many units is negative 7 from the origin? It's 7 units from the origin. So the absolute value, the distance between negative 7 and 0 is 7. So the absolute value of negative 7 would be 7. So that'd be your absolute value. Okay, so let's state the absolute value of this number here. Students, this is yours down there. We're going to do this one up here. Here's our up here. So state the absolute value of the number. So we have negative 12. What's the absolute value of negative 12? So the absolute value of negative 12 would be 12. How many units from 0 is negative 12? Well, the answer would be, if we count over here to negative 12, would be about here. How many units from the origin is negative 12? It would be 12. And that is your lesson 1.4, part 1, pre-algebra math. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.